the side here. All right. So it says, so you've got this right here, this triangle. One of the sides is 10 root 3. Now, the important thing here is that you label the correct angles, which you've got here. That means the short leg down here is half of this. So it's actually 5 square root 3 down here.
Oh, okay.
Okay. Now, if you draw the big equilateral triangle, that should make sense, because 10 square root 3, 5 square root 3, 5 square root 3, the whole length is 10 square root 3 on that. So what some students do is they just cut it in half without even knowing that it's a 30, 60, 90. And then to find the long leg, LL for long leg, you take that 5 square root 3 and multiply by the square root of 3 for the long leg. 5 square root 9 or 15. And I believe that's what it's looking for, is the altitude. All right, let me know when you're ready to move on to number 3.
Yeah.
Okay, so number 3 here. And isosceles right triangle, it has 11 square root 2 leg length. So drawing the picture is really important, right? That's really the difference between these problems and the ones we've been doing. The fact that it's isosceles means that both of these are the same, both of the sides are the same. And they're saying that's 11 square root 2, 11 square root of 2. Both legs are given. You can label 45 if you want. Now, do you remember from the other day how to go from the leg to the hypotenuse?
I don't.
So the reference triangle here, draw that underneath. There's 2 reference triangles. You need to know one for 45, 45, 45, 45, 90, and 30, 60, 90. The hypotenuse is always the leg times the square root of 2. You take whatever the leg is and multiply by the square root of 2. So if you want to label this C or H, it's 11 square root 2 times the square root of 2, which is 11 square root 4, or 11 times 2, which is 22. Now, I just noticed this. We need units. I didn't put units in the first couple, but you definitely need units here. So let's go back and do that. So this one doesn't have units, but number 1 did. So we want to add the word meters or M there. It all of a sudden in this class they emphasize units. It's just that you don't see them for the whole year, and then all of a sudden it's like, oh yeah, units matter. So okay. Number 4 looks like, let me see here, 2 root 2 plus x squared equals 6 squared. Okay, so just a little bit of modification of what you have here. It's really close. I like that you've tried to do it on your own. All right, let me snip that in. All right, so let's just solve the triangle. We'll worry about, is it a Pythagorean triple in a moment here. So your setup's great. 2 squared 2 squared plus x squared equals 6 squared. Totally perfect. Okay. Now, whenever you have 2 things inside a square, you have to square both of them. So in this case, like a is 2, so that's 2 squared. B is the square root of 2. So you're squaring a square root. And when you square a square root, like these undo each other. So the result is just 2. So like the square root of 3 squared is 3, the square root of 8 squared is 8. Like whatever's under the root becomes that this Is that okay?
Yeah.
All right, so we're bringing this 2 squared down. That's 4. 4 times 2 is 8. So this right here should be 8 plus x squared equals 36. Subtract 8 from both sides, so you get x squared equals 28. Square root. So it's x equals square root of 28. Do you remember us reducing these? I don't know if we've done that.
Yeah.
Okay, so you always start with 2. So 2, 2 and 14, 2 and 7. You look for pairs. There's a pair of 2s here. So it's 2 square root 7 is your X value. So this is what it's looking for. I mean, that's the final answer. That's the leg here.
Wait, 1 second. I'm still writing it down.
Sure. Sorry. I know I'm going a little too fast. I'm a little excited. Amped up on coffee already.
Okay.
So just to review here, you're using the Pythagorean theorem. That was perfect. All I did was jump in and say, okay, we didn't quite simplify this correctly. Once you do that, you have to take a square root of both sides and reduce the root.
Okay.
Now the question as to whether it is a Pythagorean triple. So triples, they have to be whole numbers. Well, that's not true. They start out as whole numbers. Okay.
Mhm.
So how do we want to do this? So
Um,
I'm trying to think here, like if your teacher's giving you something like the number 5 is, but I don't think 4 is, just based on the way it's presented.
mhm.
So triples would be like 3, 4, and 5. 5, 12, 13. Notice that these all work out nicely.
Uh-huh.
I would say yours don't. I would say like having a square root of 7 isn't really all that kind.
Yeah.
Nice, friendly. So I guess I would answer that no
Okay.
on there. So five is completely correct. This one is a Pythagorean triple. Do you need to say which one it comes from? Do you know?
What do you mean?
So like I mentioned up above here, 3, 4, 5 is a triple, but then there's
Um,
multipliers. So like this one is 18, 24, and 30. You're multiplying each of these numbers by 6.
uh-huh.
And that's what makes it a triple. So it's base, like its base triple is this one, and then it comes from so you could multiply 3, 4, 5 by any number, and that gives you the triple.
I think we could just say it's yes.
Okay. You know your teacher, so that's why I'm asking. All right. So 6 looks real good here. 6 is so this is great. X squared plus 9 squared is always the 2 legs equals that squared. That's correct. That's correct. So it's just a matter of like, well, how do I even reduce this 175? So you start with the prime numbers. The smallest prime number is 2. 2 doesn't work. I mean, it's not even, so 2 doesn't work. But does
Mhm.
3 work? It's like, well, I don't know. What's the rule for 3? We could go to a calculator, right? You could just divide, but the faster way is to add the digits. 1 plus 7 plus 5. That's 13. It's not a multiple 3. So 3 does not work. So then you try 5. 5 does work. 5 and 35.
Mhm.
And then 5 and 7. So 5 square root of 7 is your final answer for that.
Okay.
Any questions on that? Because 7, 8, 9 kind of moved to a different types of problems.
No, no questions yet.
Great. Okay, find the missing side lengths needed to find the area of the triangle. Answer as a decimal to hundredths. So whenever you see rounding, you don't have to do the whole radical reducing stuff.
Mhm.
That's only needed when it says to find the simplified radical. But here we're trying to find the area. Do you remember the area formula for maybe a previous class?
I don't.
It's base times height divided by 2.
Oh, yeah.
So the base is the thing that it sits on, typically, or rests on, and the height is the other dimension there. So we actually don't need the 30 for the area.
Mhm.
but we need X. Okay. So we need to first find X, which we'll calculate now. So that's like you've been doing. X squared plus 15 squared equals 30 squared. So this is 900. This is 225. So X squared equals, what is that, 675? So here's the nice thing is you actually don't need to reduce this right now. You can just leave that at it as is.
Mhm.
Like you don't have to do the whole, finding primes, all that stuff, because you're going to use it in the area formula. Okay.
Oh, okay.
Right. Like when you're using a value, unless you're like, this is the final value, then you'd have to do some, because we're going to use it in here. So your area is the square root of 675 times 15 divided by 2. Okay. Now, what kind of calculator are you using again, if you don't mind me asking?
I usually use like a TI-84. I
Okay.
don't have it in front of me right now though.
Okay. So here's what I do recommend for students that don't have it right there with them. In the chat there, I just sent you a link to the Desmos Scientific, and it's very intuitive. Like you enter it kind of exactly the way it's shown.
Mhm.
So I would encourage you to do this one that way. I'm going to snip in what to type so you can see that.
Mhm.
If you don't mind here, you go there to that link. If you type this in, it will give you the correct answer. Then we can talk about rounding if needed.
Okay, wait, sorry. I'm like, the tabs are like all weird.
Yeah, take your time. Take your time. It's important that you can do this because we're going to need to do it for a couple of problems here. So I don't want you to rush through this.
Okay, is it 194.855?
So we're only going out to 2 decimal places. So
Oh, okay. Yeah, yeah, yeah.
you're real close there. 0.86, because
Yeah.
there's 2 5s after the 6, so the second one rounds up. Good. I'm glad
I
you're able
keep
to do.
forgetting to round.
Yeah. Okay, so the next problem is going to be really similar. So let's take a look at that. Let me know when you're ready for us to move on to number 8.
Okay, I'm ready.
Okay. All right, find the missing side lengths needed to find the area of the rectangle. So the area of a rectangle is base times height. So the base is down here. The height, you can see the height is given as 6. So we basically need to find X. We'll call that X. So yet again, we're using the Pythagorean theorem. We need to determine X. X squared plus 6 squared equals 11.5 squared. So again, it's one of the nice things with that calculator there is you can actually let it do some of these calculations for you. You can say, okay, X squared is 11.5 squared minus 6 squared. So you can actually enter it like that in the calculator,
Mhm.
or you can do the full calculation. Say, okay, well, it's the square root of that.
Mhm.
And you can either leave it or you can round it. If you're going to round it, let's round it to like 4 decimal places for that one there. So
Okay,
let's go.
so 9.81 07 is what I
Yes.
got.
Yeah, that's good. So the rule of thumb here is like whatever your final answer is rounded to, you want to go out double that much for intermediate calculations. So 100th
Mhm.
is 2 decimal places. We got to 4. The area of the rectangle is base 9.8107 times 6. So go ahead and calculate that to the nearest hundredth for me, please.
So 58.86.
Good. And there's no units. Usually there's units. Like let's just say, for example, this was centimeters and centimeters. Your answer would be centimeters squared.
Mhm.
That's pretty standard in this course. So I'm surprised they're not in these problems, but I didn't make them. So I can't comment on that. All right, so let's move on to number 9.
Mhm.
All right, so it says to decide whether the triangle is right, acute, or obtuse. So if a squared plus b squared equals c squared, we know that's a right triangle. That's all those Pythagorean triples. Now the harder one is like, well, which one is acute and obtuse? Is it a squared plus b squared less than c squared? Is acute or obtuse? Which one is this? Do you remember from the other day, or do you have your notes from the other day to tell me?
Um, I'm just like guessing, but
We
is
don't want to guess. Guessing is bad.
okay. Then I don't know.
The reason guessing is bad here is because it you'll remember incorrectly if you do that. So we made a simple example the other day where we said, okay, let's say you spread the 3 and the 4 further apart. Okay, this length, which was 5, had to get bigger. Okay, so now all of a sudden the 3 squared plus the 4 squared is less than this new number here to make this work, and this is an obtuse triangle.
Mhm.
Okay, and this is how I remember, because I'm really bad with formulas, truthfully. Like I don't want to remember this, it's too much. So I always try to figure out a way to remember it without remembering it.
I get that.
Now, what do you think will happen on a test? Will you get a reference sheet? Will you get these on the board? Will you have to remember it? What's kind of the
I think we might have to remember it.
okay? So you know now you've got to do that. Now you have to put them in order: A, B, and C. A is less than B is less than C. 4, 7, and 8.
Mhm.
So once you have the sides in order, and you know which of the 3 possibilities it could be, 4 squared plus 7 squared, how does that compare to 8 squared? So,
It's greater than.
yeah, so this is an acute. Another option, which I don't think will get you full credit, is you could try to draw this. I might have tried that the other night. It's like if you say, okay, well, that's
Oh
8
yeah.
and that's 7, like, I mean, that kind of looks like an acute triangle. Maybe, maybe not. I don't know. My drawing's not that good, so that's why I don't do that. So your choice if you want to play that game of, trying to draw it.
I like the numbers better.
Yeah, me too. All right, okay, so 10, 11, 12 are really, really similar here. Okay, basically you have to put them in order. That's your recipe here. So A less than B less than C. So this one is 13 squared plus 14 squared. How does that compare to 27 squared? So if you want to grab a calculator, and I'll snip in the rule if we need it.
Mhm. Okay. 8. So 27 is greater than, so it's obtuse.
Like this, or is
Yeah,
it the other way?
like that.
Okay. So this one is obtuse, yes. So for 11, please do the same thing.
It's a right triangle.
Okay.
Because
So these are perfectly equal to this.
yes.
I'm actually shocked by that. So, but I will take your word for it because, you know, so this one is a right triangle. You can't do it by just looking at it, which is what I tried to do. I said, oh, that looks to be, I actually thought it was a cute with just kind of looking at it. So don't do that. All right. Number 12 here, same thing. It, if two of the lengths are the same, you just choose which one you want it to be. So this is 9 squared plus 9 squared, 14 squared.
So A and B are less than C.
Okay.
And so that's obtuse.
Yeah, I'm surprised we've had a bunch of obtuse. Well, that's just the way it goes. All right, so we're up to the problems 13 through 18. And we should do these in order of like the same types of problems. Like 13 is a 45, 45, 90. And we should do all the 45, 45, 90s together.
Okay.
And if you can on a test or quiz, I would strongly recommend doing that. So the reference triangle, it's really important to know this as well. This is another one of those things that just, it saves you so much time on the tests here. So got x root 2. Which side are they giving you? Are they giving you the leg or the hypotenuse in this problem?
The leg.
They're the leg. So you know that x is equal to 3. But when you say x, what you're referring to is you're like the leg is 3. To find the hypotenuse, you take the leg and multiply it by the square root of 2. Okay, so
So the 3 radical 2?
Yes. Okay, and then similarly, what is the other leg? If you
3.
already know that it's 3, yeah. Or I guess it's y. Looks like it'll be okay. All right, let's do 15. Come back to 14. So see if you can do this one on your own. It's the same setup. I'll draw the reference triangle if you want. Or that x root 2. A little more work involved because you got to get rid of that root 2, but we've done this before. So give it a try. If you have questions, please ask.
Would x be 6 radical 2?
Yes. And when you say x, you're referring to the leg of the reference
Oh,
triangle, right?
yes.
Which could be, in this case it is like it is in this problem. It's that x. Okay. Just happens to be the same. All right.
And then x and y would both be 6 radical 2.
You got it. All right. So when I look at that grouping of 13, I'm sorry, 13 through 18, there are only 2 45, 45, 90s, and the rest are the 30, 60, 90s. Why do you think that is? Why do you think your teacher's giving you more of the second one compared to the first?
Because I feel like the first one's like easier.
Exactly. And you should expect that. You should expect more 30, 60, 90s on the test or the quiz. So let's go look at 13 here. So just like the previous problem, you want to draw the reference triangle. Okay, now 30° is always across from the x. The hypotenuse is 2x. The long leg is x root 3. Which are they giving you in this problem? Are they giving you the
hypotenuse.
hypotenuse? You set the known side equal to the reference side, or in this case, 2x equals to 20, not 200. So x is 10, but that
Mhm.
refers to the short leg, okay, which in this case is y. So sometimes it's good to even write that short leg, x is the short leg, y is 10.
And then the long leg would be 10 radical 3.
Exactly, exactly. It's just so easy to write x and y as wrong, and your teacher doesn't have any way to know like what you were thinking when you did the problem. So you got to be very careful about what you're writing down.
Mhm.
All right, number 16.
Yeah.
Okay. So again, draw the reference triangle here, 60°, 30°. I always start with the 30, so that's x, 2x, x root 3.
Mhm.
They've nicely given you x. That's the easiest case.
Okay, so the hypotenuse is 22.
Yes,
And then y is 11 radical 3.
yes. So notice there's almost no work once you get this down,
Mhm.
which makes it even harder to get partial credit. Like, I'm not suggesting you need to, I'm not suggesting you need to show work. I'm just saying, like, be really certain of your answers. But you might also ask your teacher, like, hey, do I need to show work here? Because these are all kind of, easy at this point when I've been working through them, and see what they
Mhm.
say. So, that way you know what to expect. All right, number 17. Number 17
Yes.
here, find x and y. So again, like, what are they actually giving me here? Here's the 30° angle, that's x, 2x for the hypotenuse, and x root 3. So they're giving you, and this is the hardest case, they're giving you the long leg. So you have to set 27 equal to x root 3.
Oh.
So this is kind of like one of those earlier problems I had you do where you have to divide both sides by the root.
Mhm.
So can you do that for us and let me know what you come up with?
Yeah. That'd be like 9 radical 3, right?
Yes. And that in this case is the short leg, which is x.
And then y would be 18 radical 3.
Yes, you got it. Any questions on that?
No.
Okay, so just before we go to the next problem, just a reminder again that the short leg is always across from 30. The long leg is across from the 60. So I'd like you to try 18 on your own here. You
Okay.
can always ask me questions, but it's really no different than what we've been doing so far. You set the known side equal to the reference side and solve.
Would x be like 6.5 radical 3?
When you say x, are you referring
Oh,
to the reference x or not?
um, like 2x equals 13 radical 3.
So in this
Zero.
case, the hypotenuse is over here on the right. It's the
Uh-huh.
hypotenuse all the way across from the 90.
Oh, okay.
And the 30.
Oh, I see my mistake actually.
So see if you can work it out from there.
I always mix up where like the 2x and the x radical 3 go. So y would equal 13.
Yes.
And then the x would equal 26.
Yes, very good. Okay, so you're doing really well. The next few problems here are kind of they're combinations of the two types of triangles, I believe. So they're not difficult. They're just because they combine two or more things. Sometimes it's easy to, use the wrong rule as we talked about. So we want to find the perimeter of the triangle in this problem, which means we need this length over here on the right, and we need these lengths down here. Okay. And sometimes it's good to actually redraw the triangle that you're going to start with. 5 root 2. What would A and B be in this 45, 45, 90 triangle?
Um, um,
So how do you go from the,
would it be
and
5?
yes, yes. And sometimes you got to go back and look at like, one of the ones you did and say like 13 or 15. Yeah, these are 5. And then you label those in the drawing. And then now you can go back and you can redraw the other triangle. So by sort of like making just the triangle, you separate yourself from the entire problem. You don't have so many things to look at here. Are you given the short leg, long leg, or the hypotenuse?
Short leg.
Short leg. So to find the hypotenuse, you double it. How about the long leg?
You do x radical 2.
3.
3.
Yes.
Wait, when do we know when to do radical 2 versus radical 3?
So notice this is a 30, 60, 90 triangle.
Uh-huh.
And the other one was a 45, 45, 90 triangle. So different rules for each one,
Oh,
right? You gotta, it's like you have two paths you're going down, right? Is it a 30, 60, 90? Is it a 45, 45, 90? And you have to have two separate thinkings.
oh, okay.
So again, back to this problem here. I'm not drawing the reference triangle. It is good to do, but we're doubling the short leg. And then the long leg is 5 root 3. So going back to your triangle, those are the pieces of information that you need.
Okay.
All right, so this becomes this is everything. Once you have all the sides labeled, the perimeter, you're just walking around the big triangle. So you can think of a starting point if you want. 5 root 2 plus 5, that's this one down here, plus 5 root 3 plus 10, and go back to that Desmos Scientific and see what you come up with on that for this.
Okay. 30.73.
Yes. Very good. So these are much more involved, more steps, more of everything. So for number 20, we did an equilateral triangle on the other, I think on the other side of the page. And that would be really helpful to look at when you're like, if I wasn't here, if you're like, hey, what I even, go look for another problem like this one. Yeah. Equilateral triangle. So we talked about that all 3 sides are 8 in an equilateral triangle. What do you know about this length down here at the bottom? Then it is 8, but what do you know about each of these sections?
Oh, then like 1/2 would be 4.
Yes, exactly. So you can draw that triangle if you want. That's 4, that's 8. So this is the short leg, this is the hypotenuse. All 3 angles are 60, but that one up here that you cut in half is 30. So notice they're giving you the short leg and the hypotenuse that you can go between.
Mhm. Mhm.
So what would the long leg be in this one?
8.
The hypotenuse is 8.
Oh,
Hypotenuse is
okay.
8, okay.
So that'd be 4 radical 3.
Yes, yes, very good. So the area of a triangle is base times height divided by 2. Your base, and this is where you got to be careful. It's the base of the whole triangle. It's not just this one we've been doing. The base is 8. Because that's the one going all the way across.
Mhm.
The height is what you just found, 4 square root 3 divided by 2. So go to calculator, let me know what you come up with on that.
Okay, I just got 27.1. I mean 71.
Yes, yes, good. And this has units this time. All of a sudden your teacher threw in units. So it's inches squared or square inches, because you take the inches, multiply by the other inches, and you get inches squared, square inches.
Okay.
All right, last problem on this page. Let's see here. Find X, Y, and Z. So this one probably should have been done before the others, because there's no combination. You just work around the triangle to find the side lengths. But really important to figure out, well, what kind of triangle do I even have? And I think that's why this is here. It's kind of a combination of everything, because they're not giving you any angle measures. Okay.
Mhm.
This kind of leads into, I don't know if you saw this there's like a small triangle, a medium triangle, and a large triangle. Did you see that at all in class with proportions?
I don't think so.
Okay, we don't need it for this problem, but it's one of those things where you could need it. So the one on the left here, I'll do that. I'll grab that one and just put that in red here. This triangle, how do you find X based on your kind of your toolbox here?
You'd divide 20 by 2.
This is you don't know the angles. Like you can't presume that this is a 30,
Oh,
60,
okay.
90. You could if this were 10, because it's the short leg.
Okay.
So you have to use the one we start out with, which is the Pythagorean theorem. A squared plus B squared equals C squared.
Oh, okay.
So X squared plus 12 squared equals 20 squared. So this is X squared equals 400 minus 144. It does work out nicely. You want to calculate that for us, please?
1 second. Okay. 16.
16, yeah. So y is 16 plus 9, which is 25. That's nice. Got that. To find z, just draw in another triangle here. To find z, you can use Pythagorean theorem. The fact that 16 was a nice number should have said, oh, maybe it was a Pythagorean triple. Z is a nice number as well, but if you're not sure, if you're like, I don't really know, you just go back to Pythagorean theorem.
Oh, okay.
You can always go back to that. Like that's in your toolbox is like, all right, a squared plus b squared equals c squared.
Okay, I got 15.
Yes. Yes, very good. Okay, so that completes this page here. We've got a little time left here. Is there something else you would like to work on?
I don't think there's anything else I have a question on right now.
Okay. I can give you some problems. We can stop right here. What would you like to do?
Do you want to do another practice problem?
Sure. All right, so let's go back here. So again, the challenge here is like you have to be able to quickly distinguish between these two, right?
Mm-hmm.
And I've drawn them a number of times and you got them all over your notes, but like really you have to either write this every time or you have to know it so well that you know you don't need to write it each time. X 2x x root 3, because all I'm going to do is give you a problem where I'm either giving you in a 45 45 90 a leg or a hypotenuse. That's it.
Mm-hmm.
Or in the 30 60 90 I'm giving you short leg, hypotenuse, or long leg. That's it. Like there's no tricks. There's only 5 different types of problems that you can be given here.
Mm-hmm.
So I guess we'll go back and forth here. So let's say I give you something like this, and I tell you that this is 10 root 6, 10 root 6, and I want you to find x and y.
Would X be 10 radical 3?
Good.
Oh, okay, good.
What about y?
And then Y would be 10 radical 3 as well.
Good. Very good. All right. Let's give you another one here to look at. All right, so this is a 30, 60, 90. So this is the harder one. You have to decide whether I'm giving you the short leg, long leg, or hypotenuse.
Hey, that's the long leg, right?
That's right. So you have to tell me whether this is which, or you want to decide is it x, 2x, or x root 3?
Okay. Would it be okay? I'm kind of like confused because I don't know which one to use.
So the short leg is always across from 30.
Mm-hmm.
So is that what I'm giving you?
Oh,
The hypotenuse is always across from the 90.
okay.
So in this problem, I'm giving you the long leg.
Mm-hmm. Okay, it's X 3 radical 3.
So what is the value of x?
X should be 8 radical 3.
Okay, now is that this x here, or is it something else?
It's that X,
It
the
is.
short leg.
It is. Okay, and how about the hypotenuse?
And the hypotenuse is 48.
So you're doubling the short leg.
Oh,
doubling the
okay,
short leg.
okay. So then it's 16 radical 3.
Yes. All right, very good. Do you want another problem?
Sure.
All right, let's do it. So let's do. This is a 45, 45, 90. I'll tell you that this is 18 square root of 3. This one's a little bit tougher. So am I giving you the long leg, short leg, or the hypotenuse?
The hypotenuse.
So this one you set equal to x square root 2. We've not done this before. You have to divide both sides by the square root of 2, which maybe is a little bit awkward because 3 doesn't go into 2.
Yeah.
Okay, so it's like, what do you do here? And it's a good question. That's why we're doing it. It's like, well, let's take a look. So you end up rationalizing. Oops. You end up rationalizing, which is multiplying the top and bottom by the square root of 2.
Mm-hmm.
So in the top, it becomes 18 square root of 6. But what does the bottom become?
Radical 4.
Radical 4, which is 2.
Yeah.
And then, oops, you put you put that under the 9, so this becomes 9 square root 6 like that.
Okay.
All right, last problem here. This is 30 degrees. Let's say this is 8 square root 2. Can you tell me what B and C are in this problem?
Would C be 16 radical 2?
Good.
This. And then would be 8 radical 6?
Yes, perfect. Very good. All right, we're going to go ahead and stop here for today.